Another day, another thing I learned. How do facial expressions work? There are 20 muscles in the face that can be moved in different combinations. There are two kinds of facial expressions, voluntary and involuntary. A lot of study has gone into reading facial expressions, and there are many theories about whether they reveal inner thinking or not. Voluntary and involuntary facial expressions come from different neural pathways, but all of them use the same muscles. The facial muscles don't only make facial expressions. They have many different jobs. We have 5 muscles that let us open and close our mouths to chew and speak. We have 3 muscles that we use to open and close our eyes. Without these, we couldn't blink to remove dirt from our eyes or lubricate them, and we couldn't close our eyes to protect them. There are 2 muscles to enlarge or narrow our nostrils and another muscle that pulls the nose up. These allow us to search for and focus on scents. There are also 2 muscles that let some people move their ears. These are probably a vestigial function, such as wisdom teeth and goosebumps. The muscle would have allowed people to turn their ears towards a sound to hear it better and triangulate direction, similar to the way cats can. Here are some of the muscles and the facial expressions they produce. They can also be performed in combinations to make thousands of different expressions. The occipitofrontalis muscle raises the eyebrows to show surprise and can retract the scalp. The corrugator supercilii lowers the eyebrows for scowling and frowning. The nasalis flares the nostrils for emotions like fear or anger. The levator labii superioris raises the upper lip for a sneer. The depressor labii inferioris lowers the lower lip for pouting, and the depressor angulus oris opens the mouth and moves the jaw. The zygomaticus major pulls the corners of the mouth for smiling. It is often said that you need more muscles to smile than you do to frown. Is that true? To frown, you need 4 pairs of muscles. You need to pull down the eyebrows, drop the lower lip, and turn down the corners of the mouth. To smile, you technically only need 2 muscles to pull up the corners of the mouth, but a full, genuine smile can use 10 pairs of muscles because it works on your eyes, eyebrows, and cheeks as well. So, yes, it is true. All of the muscles in the face are controlled by branches of nerves that come off the facial nerve. The nerve comes from the brainstem and heads to a point just below the ear where it breaks into 5 branches. From the top of the face to the bottom, these are the temporal branch, the zygomatic branch, the buccal branch, the marginal mandibular branch, and the cervical branch. Facial expressions can be divided into voluntary and involuntary. Involuntary facial expressions are made in the same way any conscious movement is made. A signal is sent from the primary motor cortex, down the facial nerve, along the relevant branch, and into the required facial muscle. A voluntary facial expression would be something pretending to smile, lying, or acting. Involuntary facial expressions are a little more difficult to explain because they are triggered by emotions and not a conscious brain signal. Unconscious facial expressions are caused by emotional states, and these in turn come from different parts of the brain. The amygdala is one of the areas in the brain that does most of the processing of memory, decision-making, and emotions. When different emotional states arise, they are processed by the amygdala and other areas of the brain, which then send signals down the facial nerve to activate different facial muscles. When we have a positive stimulus, such as a nice smell, more electrical signals are sent to the muscles that signal a positive emotion, and when we have more negative stimulus, more signals are sent to the muscles that work the negative facial expressions. These facial expressions are not learned because blind people perform them as well. Over time, we have evolved the specific facial expressions we have because signaling to other members of our species is obviously important for our survival. Recognizing other people's expressions is also vital, and the superior temporal sulcus is responsible for it. It works by analyzing which muscles in someone's face are being activated. AI can be trained to recognize some human expressions, but not nearly as many as we can recognize. And this is what I learned today.